All right, good evening, everyone. How are you doing? I didn't hear that. How are you doing? Woo. Yes, well, good evening. Welcome. It's really a pleasure to have you here. Thank you for coming. Thank you for the one who are tuning in online as well. Very excited to kick off C2V's Year 3. We have an amazing lineup of innovative companies that will present tonight. So we're going to have a great time. It's a bit of a special thing. I do live in Boston, so I'm happy to do this at home. I play home, if you will, and I'm happy to hear that the Celtics won as well last night. Fun fact, I used to live in Montreal, and when I knew I would move here, I did a recon tour. So I drove down to Boston, and it was kind of winter and not so nice. And to be honest, I was happy in Montreal, and I didn't want to move. And one of the first things I actually did when we arrived here is stop by Greentown Labs. I heard there was this climate tech incubator, and I was wondering, what is this? I entered the space. It was completely empty because people were on holidays, but I was so inspired by the space. And I told myself, it was 2018, I told myself one day I will work here. And 2 years later, I got the job with C2V, and tonight I'm really happy to be on the stage running this amazing program. So it's really a great pleasure to introduce you to Kevin Taylor, who is the CFO and Interim CEO at Greentown Labs.
Thank you very much. So good evening, everyone, and welcome to our kickoff event for Year 3 of the C2V initiative. As Fred said, my name is Kevin Taylor, and I am the interim CEO and CFO of Greentown Labs, and it is my pleasure this evening to welcome all of you to Greentown, Somerville, one of our 2 campuses in North America. I'm thankful that you are here with us tonight to celebrate the beginning of what I know will be a wonderful, amazing year, another wonderful and amazing year for C2V. We at Greentown, and actually with the Greentown team, just raise your hands. You saw them as you came in. You saw them walking around. Greentown team, raise your hands. We are delighted on behalf of Greentown to be welcoming you tonight and to be a collaborator in this incredible initiative along with Urban Future Labs and Fraunhofer USA. How many of you are here at our Somerville campus for the very first time? Would you raise your hands? Look around you. We are glad that you are here especially. You may put your hands down. For those of you who are visiting for the first time, allow me to share just a little bit about what makes us special. Our mission here at Greentown is to build an inclusive community that convenes, connects, and inspires entrepreneurs and ecosystems to advance climate solutions. We like to think of ourselves as a global community of entrepreneurs, of corporate partners, investors, and policymakers who are working toward the same ambitious goal, solving the climate crisis through entrepreneurship and collaboration. And you might be asking yourself, well, how is it that we do that? Well, we provide a supportive ecosystem that allows startups to test, scale, and commercialize their breakthrough technologies that address some of the world's most pressing climate challenges. Over the past 12 years, we have helped more than 500 startups raise over $4 billion in funding. Let me say that again. More than 500 startups raised more than $4 billion in funding, achievements that would not have been made possible without the power of our community and our ecosystem. Collaboration is at the heart of everything that we do, and that's why we partner with some of the world's leading corporations to help our startups scale their solutions and accelerate the pace of innovation, and many of those are listed on the wall behind me. Corporate partners provide critical resources and pathways to market for climate tech startups, and those partnerships can be game-changing relationships in our startups' ability to scale and deploy their technologies. And it is our hope at Greentown that C2V continues to fuel these game-changing collaborations, and that we would build a more powerful carbon tech ecosystem that can empower inspiring entrepreneurs like the ones that you are going to see and hear from tonight, and ultimately to win the climate tech battle. Now, in addition to being the CFO and the interim CEO, I'm also a pastor, and so I know that when you begin to call people's names, you inevitably leave somebody out. So let me just say at the outset that each of you is special, and we're glad that all of you are here. But there are some people that we would like to especially thank tonight, and that is that they include the whole C2V team for their tireless work to make the program tonight a success. Can we give the C2V team a round of applause? Thank you. The UFL and Fraunhofer USA teams for being incredible partners. Them a round of applause, please. The UFL and Fraunhofer USA, yes. And so I'm going to ask for your applause after each category. And again, if I've left anybody out, you're special. So those who I'm calling and those who I should have called, we love you too, all right? So from the government sector, the consulate, the General of Canada in New York, as well as NYSERDA, who was particularly instrumental for C2V as the source of the larging funding. So can you give our government sponsors a round of applause? Our carbon tech experts and NGOs, Carbon 180, Carbon Direct, Carbon Plan, Circular Carbon Network, and X Prize. Can you give them a round of applause? Our corporate partners, Fluor, Johnston Matthey, NRG, Unilever, WL Gore and Associates. Would you give our corporates a round of applause? And tonight, we are thrilled to welcome our newest CLC member, BASF. As one of Greentown's longstanding partners, BASF has a diverse and global value chain. You can come on, that are a great fit for many carbon tech innovations, and we are so excited to welcome them to C2V. Can you give BASF a round of applause? And before I turn it over to my friend Tom, who told me that I shouldn't step my game up the way he thinks that I did on Monday night when we were together before. Before I turn it over to him, I'd like to finish by thanking each and every one of you for being in our audience tonight. You are an important part of this ecosystem that makes innovation possible, and so I thank you for being here. And now it's my pleasure to turn the mic over to my friend Tom Holcombe, the head of BASF's Northeast Research Alliance, NORA, that just celebrated on Monday. Tom, over to you.
Thank you so much, Kevin. It makes so much more sense now. Your speaking abilities are something I think I will never be able to match, given your hobby or second passion or other job, pastor, something very admirable. So thank you very much for giving me this opportunity tonight. Yes, as a longtime partner, 5+ years working with Greentown, I feel like the timing was right. We had just finished our Go Move 2022 program with many overlapping talents. I know we're going to be working together with Dominique and Marina, and so I felt like the timing was perfect. And really, we don't have my slide. I feel like even more important than the continuing and strengthening of the relationship with Greentown is the engagement that we have here with the startups, the cohort that's going to be cohort 3. So cohort 2, we already worked with in the Go Move 2022 campaign and program, and as BASF tries to reach our 2050 net zero target and 2030 targets, it won't be possible without open innovation. And that's what I'm here for in North America, is the open innovation part of BASF, to find and work with really the entrepreneurs in North America that are going to enable our sustainability goals. It seems like we should just continue our trend linearly, but actually we've done pretty much everything we can with OpEx, and we will need your help. So I'm really looking forward to the pitches ahead and working with all of you. And with that, I'll pass it back to Fred.
Very excited to welcome BASF to the C2V family. Kevin stole my notes, so I'm going to do this by my memory. One thing before we go to the finalists. This one. I want to highlight the importance of an ecosystem. Tom mentioned net zero is not going to happen in a silo. We need different components working together. So we need corporates that will build and buy at scale. We need government that will catalyze through policies. And we need carbon tech experts and non-for-profits who will guide scaling with science and facts. So that's what we need to scale carbon tech. Of course, we also need the innovators, the entrepreneurs who are building these companies and taking a lot of risks. So C2V is here to help these young companies with the risks they are taking. We had, amazing companies over the last 2 years out of over 230 applicants. And what's important to us is that we don't focus on a specific technology and solution, but we are very holistic about how we think around the carbon management value chains. So you can see from innovations on the point source capture to, of course, all the conversion processes, but also carbon removal, biochar. There is a wide diversity of approaches, and we want to support them all, and we will keep the cohort portfolio very diverse to keep exploring new technologies, new business models. I'm not going to go through all the numbers. These are some metrics that demonstrate the outcomes. I think what we really care about is how the Carbon Tech Leadership Council members work with the startups. They are not here only to support the initiative, they are here to work with the innovators. And one good example of that partnership was when in year one, Carbon Free was working with Fluor and used C2V to really accelerate and cement their relationship with Fluor and sign a partnership agreement with Fluor in 2021. 2 years later, that translated into a partnership with BP to develop and deploy the technology, as well as with US Steel. And they are now signed an MOU with US Steel to deploy their first commercial plant at 50,000 tons per year. And that's really because they were working with Fluor to de-risk the technology and identify use cases that work in the industry. So that was about year one and year two, and now we want to hear about year three. We had a record number of applicants, 161, from all over the world, and we were extremely pleased with the quality and the diversity from the geographies that we received. It was a pretty tough job to select the 12 finalists that you will hear tonight. And I want to say to everyone who applied who are not here tonight, there will be other opportunities, and there was a lot of high quality applications. So really thank you for applying, and there will be other opportunities. We had a good representation across the different solutions. This year we had 4 technology-focused areas for our call for application. And again, it's about the diversity of solutions and not focusing on one particular items. So with that kind of background, we'll jump into the startup presentation, the most exciting part of this evening, and you will hear from the 12 finalists that you will see are again covering very different aspects. From these 12 finalists, we will have the hard job to select a cohort from 6 to 8 companies that we will announce on June 21st. So, with that, I have the pleasure to call Capro-X on the stage, and we'll hear how you can make clean drinking water and at the same time capture CO2 from the air. Leo, Kelly, welcome.
Good evening, good morning, or good afternoon, everyone, wherever you are. It's a great honor to be here on the stage representing Capro-X. My name is Leo Clerc.
And I am Callie Oberon, the Director of Policy and Stakeholder Engagement. And we're very excited to be here today representing Capro-X. So I want to tell you a little bit about what our approach is to direct air capture. So we use a source of salt water, air, and electricity to create liquid solvent and capture CO2 from the air. And our approach is focusing on both capturing the CO2, but also also producing value-added products from this process. So you'll see we produce carbonate, so that's how the CO2 is stored in a solid from the process. We can also produce fresh water. So Frederic mentioned this. By taking salt water to capture CO2, we take the salts out and produce fresh water on the other side. We can also produce hydrochloric acid or green hydrogen and green chlorine gas, which can be used in industrial processes. So we have a very ambitious goal ahead to remove ideally gigatons of CO2 from the atmosphere, and this needs to be done at a price point that's feasible. So this is our approach, the business mindset. So our theory of change is obviously we're tackling carbon, removing it from the atmosphere, but we're also supporting adaptation by producing fresh water. So we can pair up with desalination facilities, take the brine from their process and use that to produce additional fresh water. And we can also power our facility with renewable energy, so we don't need a source of heat, which is really exciting. And this can also encourage additional production of renewable energy by having that source of demand. So we're very excited to be a DAC process that is a provider of fresh water and not necessarily one that consumes valuable and scarce fresh water supplies, especially in countries around the world or regions that may not have abundant freshwater resources.
And we very much care about making sure that there is just an equitable transition, and that we do believe that this carbon removal movement should not be only US or the global centric. So this is exactly why we are really trying to advance environmental and climate justice across the globe. So this map shows we are really serious about the global deployment. So we are very proud to let you know that we've been actively developing projects across the globe, including some of the very challenging markets and countries such as Kiribati, to really make sure that no one is left behind in this journey. And this is the very first pilot project we are developing down in Palmdale in LA County in Southern California, and we are very glad to share with you that some of the partnership and the progress that we have made, which include some of the grants that we have received at Chemical Energy Commissions, as well as the technology approval from the enaDyne.
So I'll just add on to that, we're really excited about this grant for Palmdale, California for our pilot, because a big part of that is also focusing on stakeholder engagement and making sure that we are deploying these technologies in a way that is equitable and just, and that's really at the heart of what we do at Capture-6. So we're hoping to take that model and expand it globally, and would be thrilled to be part of C2B's Year 3 cohort. Thank you.
Thank you so much. Next, we'll explore how you can reinvent point source capture at scale. And for that, I have the pleasure to welcome Clément Cid from Sequester.
Thank you. So I think there is a theme. We are also based in California. My name is Dr. Clément Cid. I'm the CEO of Sequester. And I wanted to tell you a little bit first about who we are. We are a Caltech spin-off, the classic three guys in the lab. We have a cat. And the technology that we developed originally from our technical background uses carbonate salts. So you already heard about those in the previous speech. But we're using the carbonates as basically sponges for capturing CO2 in large point source emitters. Think about having affordable carbon capture that can be deployed to large point source emitters. That would mean that only for natural gas power plant, we could reduce our CO2 emissions by a gigaton. We take advantage of the US 45Q tax credit, and we can do so because our point source carbon capture technology is inexpensive. I have with me some of the material, but basically we take a carbonate sorbent that's a powder and make it into a bead. Sorry. Oh, it won't work. I'll go to the next one. And the process is relatively simple. You have the flue gas coming from the power plant, going to the sorption reactor, and in parallel, the other bed is ready for desorption. That enables us to capture more than 90% of the CO2, overall looking from capture all the way to sequestration. Where we are now with our technology, we have a large-scale prototype system that we built and developed at our facility in Los Angeles. And we're moving forward with a partner in Central California for a pilot system that will be able to capture between 1,500 and 15,000 tons of CO2. The approach to the market that we take is really looking at where the CO2 is coming from en masse. So right now, point source emitters, as I mentioned, natural gas power plants are our first target market. We're looking at plants at 50 megawatt production capacity and above, but that doesn't limit ourselves. We can use our technology for other point source emitters. Think about steel, cement production, or chemical manufacturing. The other approach is looking at, in a second step, smaller power production systems, such as combined heat and power or boilers. And with that, I'd like to thank all of you for being here. And if you have any more questions, I'll be happy to take them later on during the meeting. Thank you.
Thank you, Clément. Next up, we're going into the captivating world of direct air capture. And can you scale that through actual current CO2 end users? For that, we'll have Mark Henderson from Skytree.
Thank you. So, carbon dioxide, despite the fact that we have way too much of it in the atmosphere, has many, many uses. The problem is that it requires fossil fuels to generate carbon dioxide. This creates an unsustainable supply chain that deals with a lot of supply issues as well as price uncertainty and increasing price. And also it's a hassle operationally for these organizations to deal with moving tanks of carbon dioxide into their locations and moving them out. At Skytree, we are working with these types of industries such as vertical farming, greenhouses, mineralization to provide on-site solutions with direct air capture technology where the industries can place the machines at their location and generate CO2 from the ambient air and directly pipe it into wherever their industry is. So for example, with the vertical farm, you see on the left the Skytree system. It's working to pull in ambient air, pulls out the carbon dioxide from that, puts it in a buffer tank, connects automatically into their pre-existing carbon dioxide distribution system. With that, then they get a consistent, price-consistent supply of carbon dioxide that they don't have to worry about. It's a set it and forget it kind of a model. How it works is pretty standard direct air capture technology using amine sources to pull in ambient air with a fan, runs it through a filter, captures the CO2, uses a heat exchange process, pulls it out, we concentrate it, put it into the tank so that it can be distributed at the facility. Our machines are easy to install. They easily integrate in with the pre-existing systems that our customers have. They can scale, they can be stacked. We have a 5 kg system, which is 5 kg per day, and a 200 kg system coming onto the market, which is 200 kg per day, but they can be stacked and work together to create as much as they need. With that on-site supply, as I mentioned before, it's a set it and forget it model. We provide an uptime assurance package so they never really have to worry about it. And we replace all the filters, provide the preventive and corrective maintenance, etc. as they go with off-site monitoring that we can do with our systems. Our 5 kg system is being launched in Q3 of this year. And we're very excited that our 200 kg system, again stackable and scalable, is being released in summer of next year. We're very excited about entering this market and also excited to work with the C2B initiative. And thank you very much for your time.
Thank Thank you, Mark. We will stay in that fascinating world of DAC, but this time we're going to ask the question, can you take advantage of cold climates to capture CO2 from the air? For that, we'll have Vida from TerraFixing.
Thank you for your kind introduction. My name is Vida, and I am the co-founder of TerraFixing, a direct air carbon capture company. I'm here tonight, and I will make a bold statement. The future of scalable and affordable DAC is in cold climates, and here's why. The first point is that cold climates offer the most powerful wind power opportunities in the world. And secondly, we can sequester all of humanity's carbon emissions in northern geologic reservoirs. Our founder and CEO realized these two opportunities very early on and set out to design a direct air capture technology that was capable of taking advantage of these. And today, TerraFixing is the only company that is able to harness these two remarkable wind power and sequestration opportunities. Why is that? Because we're the only company that has specifically designed their system for cold climates. Because of our intentional engineering designs, we are able to reach costs as low as $40 per ton at the gigaton scale. Because of our technological innovation, I should mention that this $40 per ton CO2 is not just in theory. Our technology has been proven, is IP protected, third-party validated, and we are now in a scale-up phase. Because of our technological innovation, we are able to produce units that can capture 4 times more CO2 and are 4 times smaller than the competitors' units. So who is behind TerraFixing's technology? Our team of experts include PhDs, engineers, and serial entrepreneurs. We have the technical and the business expertise to lead innovation and push projects forward in order to reach the megaton capture scale by 2030. We believe that community engagement is absolutely paramount, which is why we have partnered with Indigenous communities to push our projects forward. Our pilot deployment location is going to be in Falmouth, Quebec, in collaboration with the local Indigenous communities, and this is where we will be competing for the X Prize. We have also partnered with Tug Lake Energy, which are a renewable power provider that are developing the wind power infrastructure in these 4 locations, which is what's going to enable us to reach that megaton capture scale. We have pre-sold over $200,000 worth of carbon removals, and due to our initial customer interactions, we believe that we will be one of the major players in the 2030 carbon market, which is projected to be over $800 billion, and that's in the US alone. We firmly believe that the future of direct air capture is going to be in cold climates. We are so proud to have closed our seed round and are actively selling carbon removals. So if you're looking to purchase carbon credits, come find me. My name is Vida. I'm with TerraFixing. Thank you so much for your attention.
All right, thank you, Vida. Next, we are going to explore, well, the question that everybody has, which is, what do you do with the CO2, right? So one way is to just use electrons and make chemicals. And so we're going to learn more about this with David from Dioxycle.
Thank you very much. I really didn't realize it was a question that everyone has. I hope I can answer this in the presentation. Please forgive me, I'm a little bit jet lagged, so if I start to slur my words, it's not my accent, it's really the 6-hour time difference I'm dealing with right now. So I've got 3 minutes, let's go. So on the screen right now, you can see Dioxycle's goal. We want to take renewable energy, carbon dioxide emissions, and our technology in order to make sustainable fuels, chemicals, and feedstocks. This is coming at a time where industrial CO2 emitters are experiencing some very strong tailwinds to decarbonize their process. They're being given tax incentives, They are facing volatile fossil fuel markets, and people like us, hopefully everyone in this room, is pressuring them to use sustainable feedstocks in their process. This is where Dioxycle comes in. We are making a CO2 electrolyzer, which is able to convert carbon dioxide emissions into energy-rich small molecules like ethylene and carbon monoxide, which can then be converted into commodity chemicals and fuels. I'm an academic. I'm going to do lots of sciencey bits, please forgive me. So this is what our electrolyzer looks like. It's a series of metallic plates. These plates have grooves, which are used to transport the CO2 from an emission stream into the center of the reactor where the catalytic cores are. These catalytic cores are responsible for the conversion of the CO2 from the boring form that it initially has to the interesting valuable molecule. And at Dioxycle, we are really focused on optimizing that catalytic core. We make the catalysts as efficient as we can make them, so we don't have to use as much electricity to convert the CO2. We make the internal membrane ourselves. This means we can really lower the cost of the entire technology, and we're really focused on maximizing the scale of the technology so we can convert all of that CO2 you guys have been talking about capturing. Through this process so far, we've been able to hit all of our technical milestones, and we're now at the point where we're developing our industrial demonstrator unit. And provided this unit is successful, which, touch wood, it will be, we are planning to scale up this technology, and we have a goal as a company to reach to prevent 800 megatons or more of CO2 emissions every year by 2050. I might regret that goal in the future. Just to finish up, I just want to plug our incredible team. We are 19 full-time employees in Paris and California. My co-founder, Sarah Lamaison, and myself, we both have PhDs on this topic and have worked at the University of Cambridge and Stanford University. We have an incredible head of stacks, we have an incredible team, and we have funding from the Breakthrough Energy Fellows program as well as Low Carbon Capital. Thank you very much.
Thank you, David. We're almost halfway, so how are you doing? Are you energized? Sure. We're going to take a break, not an actual break, but a break in the world of CO2 conversion. And the next finalist was not able to join us in person, so we're going to have a video instead. And you will see they do kind of interesting things in between the world of agriculture and carbon removal.
Hi, I'm Felix. I'm CEO and co-founder of InPlanet. We will be the first company sequestering more than 1 million tons of CO2 every year worldwide. And if you see this pitch until the end, you will think about this rock completely different. I have my background in business and technology. I founded 2 companies already, and I grew up on a winery in the south of Germany, where I get my passion for sustainable agriculture, but also for good and healthy food. We all know that climate change is happening, and in addition to all the reductions we have to achieve the different sectors, we have to remove CO2 from the atmosphere back to the ground. Until 2050, we have to remove every year 10 gigatons of CO2 from the atmosphere. Compared to what we have today, this is an increase of 50,000%. We have a solution for that, and it's called enhanced weathering. When it's raining, water and CO2 come into contact with each other, and a weak acid is produced, a carbonic acid. This is almost the same like a sparkling water maker at home, only in a much lower concentration. When this weak carbonic acid now comes into contact with our stone, a slow chemical reaction begins. Essentially, the minerals in the stone dissolve, and as a result of this reaction, the CO2 is fixed for more than 1,000 years, so it can no longer escape. And that's great. We at InPlanet, we're grinding those rocks and providing the rock powder to farmers in the tropics, at the moment especially in Brazil. Because studies have shown that using those rock powders in the tropics can replace chemicals and fertilizers up to 50%. So this is leading the farmer to a more sustainable way of agriculture. But at the same time, he's reducing his costs for chemicals by up to 25%. We at InPlanet, we're building a unique software platform which is connecting local farmers and local mines. At the same time, we're also developing a verification technology that we, at the end, exactly can say how much carbon is sequestered by each of our farmers. To make this, we have a great team. My co-founder Niklas have lived for many years now in Brazil, worked for different companies, and has built up a network of farmers and mines already. Also, our science team has worked on the topic of enhanced weathering and soil science for more than 20 years together. We closed our pre-seed round this year and onboarded a huge amount of farmers and also mines to our platform by spreading more than 5,000 tons of rock powder to tropical agriculture already. Now we're picking up conversations for our seed round, which is going to happen early next year. So if you're interested in sequestering carbon in megaton, but also in gigaton scale, with this simple technology, which is called ROCs, let me know. I'm really happy to chat with you at our roundtable. Thank you.
It's nice to clap because he might be watching online. Great. Well, we'll go back to what do you do with the CO2, right? You've captured it and now you want to convert it. And so the next one, it's an interesting way and using plasma as a way to convert CO2 into chemicals. For that, we have Philip from enaDyne.
Hello everybody, my name is Philip, I'm the CEO of enaDyne, and we are profitably stopping climate change by doing simple things with our technology. We recycle large amounts of carbon dioxide, we turn them into green, sustainable products, and we do that with a profitability that actually allows us to be independent of subsidies and virtual constructs like carbon credits. And we do all that with the goal to close the gap towards a fully sustainable and profitable circular carbon economy. And that, on the one hand side, allows us to sequester gigatons worth of carbon dioxide and also allows us to get rid of fossil oil and gas in the chemical industry for good. The technology I'm talking about is called enaReact, and it's the first efficiently working plasma catalysis reactor capable of turning CO2 and the hydrogen source into green sustainable fuels and also green chemicals in one single process step. At the core of the technology is this, a plasma-active, ceramics-based electrode material that makes our technology so energy efficient. So efficient, in fact, that we'll soon be able to produce green, sustainable chemicals at or even below the price of fossil alternatives. It also makes the technology extremely flexible because depending on how we functionalize our electrode material, we can produce a wide variety of C1 to C4 hydrocarbons like methanol, ethylene, propylene, or formaldehyde with great selectivity. Finally, the technology is also really scalable because, as you see there, we pursue a modular, container-based scaling approach, allowing us to mass produce the small, inexpensive units at the central location while still being able to flexibly deploy the containers to a wide variety of use cases, like in biogas plants, industrial point sources, and also in the energy sector. To accomplish that goal, we assembled a great interdisciplinary team covering all the different subdisciplines of plasma catalysis, and we surrounded them with a great and growing interdisciplinary partner network consisting of academic partners on the one hand side and lead users and industrial partners on the other. So if you are also sick of just fighting the symptoms of climate change, but want to be part of a sustainable and profitable long-term solution, you can be that right now, with us and a lot of the other guys. Thank you.
Thank you, Philippe. We'll stay in the sort of same theme, but next we'll see how you can make fabrics from CO2. And for that, I'm welcoming Benoit from Fairbrics.
Hi everyone, I'm Benoit, the co-founder and CEO of Fairbrics. Did you know that if the fashion industry was a country, it will be a closed force in terms of CO2 emission. Moreover, if nothing is done, the fashion and textile industry will have consumed 1/4 of our global budget to stay below the 1.5 degrees set by the Paris Agreement. All the fashion brands have committed to be carbon neutral by then, but how will they succeed without a solution? They need a new approach to creating fabrics. That's where Fairbrics come in. We are making sustainable fabric out of thin air. We have developed a breakthrough chemical process to convert CO2 into polyester yarns. Polyester is a material that is here to stay. It represents 60% of the market and 95% of the growth. Today it's a plastic, so for example, when you buy a t-shirt, the t-shirt is made of fibers, and the fibers are made of pellets. The pellets are made of 2 chemicals. The only thing we change at Fairbrics is the way to prepare the exact same chemicals. Instead of using fossil-based materials and emitting CO2, we are using a CO2 as a building block to create the exact same molecules. So the big advantage of our technology is that we are much more sustainable. Our process is unique by its selectivity. We can get a 95% selectivity toward a C2 compound, which is very unusual. We are using mild operating condition, and we are targeting a high-value product with a very high-value application. So we can be cost competitive and generate profit with our pilot we are building right now. And finally, what we are producing is a drop-in replacement. It's impossible to make the difference between what we are producing and what is used today, and that's something our customer love. Here you can see our first happy customer, Elena Elmerson, the CEO of H&M. We did a proof of concept with them 2 years ago. They love the results, and today they are one of our shareholders, and we've got 4 other big names that have validated our product. Fairbrics was created 5 years ago in Paris, and today we've got a pilot line building in Belgium. We are a team of 16 employees. We had the chance to have people from 15 different countries in the world, with 10 PhDs and 4 mechanical engineering today. We have raised 24 million in private equity and grants. We've got 1 patent granted and 6 pending. Sorry. It's a long-term project. So during the 5 last years, we have been very busy optimizing our process, filing patents, and finding partners for offtake agreements. Right now, we are focusing on scaling up the technology. We want to increase our production from a few kilograms per year today to a few tons per year next year. Once we have accomplished this important milestone, we'll be ready to build our first flagship factory in 2026, and we plan a commercialization in 2028. To finish, I would like to say that it's only a beginning. We are not going to stop with fashion. We've got other products in the pipeline, and we are going to make possible what was a dream yesterday, making sustainable fabric out of thin air. Thank you.
Thank you, Benoit. I have to say I'm quite pleased with the European and French representation on this finalists, and I promise it's not me. Well, next we're gonna enter a little bit of a different sphere, and we'll look at biomass and CO2 sequestered via photosynthesis. And so our first company looking at this is called Global Algae Innovation, and I have the pleasure to welcome David.
Thank you. I'm Dave Hazelbeck with Global Algae Innovations, and we are driving forward to lead the next agricultural revolution, where we change our primary production of protein and oil from land-based crops to algae, and that will create an abundant, sustainable world where there's plenty of land and water resources for both nature and to feed the population. We are primarily a technology developer. We've been working for the past 8 years to develop to bring the cost down to where we can be competitive with commodity prices. And we are focused on oil for fuels, polymers, and consumer products, and then protein for feed and food ingredients. So what's algae farming? Most people aren't familiar with algae, never seen an algae farm. I'll show you a picture of ours in a minute. But basically we're growing a single-celled microalgae in an open raceway, which is just an earthen-lined pond. We harvest that algae and it's about 50% oil and 30% protein, and then we separate that out into the various products. So why is algae important? It's really the unprecedented increase in productivity. Really, we can produce 30 times more protein and oil than the most highly productive land plants. And that's a game changer. That means 30% less land is used, so it can address the primary drivers for deforestation, and we can restore water resources. In terms of climate, we're capturing the CO2 directly into the raceways. It then gets converted into the oil and protein by photosynthesis, and the part of the oil goes into polymers, so that's sequestered. But the biggest impact we'll have is on deforestation. Every IPCC pathway to 1.5 degrees, or even some of the higher ones, require stopping and most of them require reversing deforestation. And there is no solution to that right now. The primary drivers are oil production in Southeast Asia and protein production in South America. If you don't address those drivers with something that's an order of magnitude more productive, we can't reverse deforestation and we won't be able to meet those goals. So we think algae will be a component of the solution to global climate change because of that, and that's about a 10 to 15 gigaton per year difference. As I mentioned, it will also impact water, not the focus of this conference, but it will greatly improve water resources because we use 93% less water to produce those products. And I promised a picture of our farm. This is our R&D farm. The largest raceway there is about 3 acres, and that's where we use to develop all the technologies to date, and we're working on scale up so we can bring this solution to the world. Thank you.
Thank you, David. And next we'll look at how we can turn food waste into valuable products. And for that, I have the pleasure to welcome Juan from Capro-X.
Hi everyone. Hi everyone, my name is Juan. I'm the CEO of Capro-X. Capro-X was founded to produce sustainable alternatives to greenhouse gas emitting petroleum and palm oil chemicals by using natural fermentation to turn food waste, ag waste into drop-in platform chemicals, green chemicals. So I think this is a room where we don't really need to talk about the urgency and the impact that we need to achieve in the next 25 years to make sure that our world remains the way it is today. But the big point here is that we've been talking about biofuels and bioplastics for decades and really still not seeing these products pervade into society in common uses, as well as a lot of the products that are coming onto the market now are actually using food ag to make some of these products, which is going to exacerbate problems in the future. So as a process engineer in wastewater and as a fermentation company, we really look at who's done a good job in this space. And anaerobic digestion is the most practiced fermentation on the face of the earth, treats difficult waste streams, and is done in millions of gallons of scales in volume. And one small problem is that it just makes a low-value product of biogas, so electricity and heat. So Capro-X uses the same kinds of open culture fermentation, so non-GMO, highly scalable fermentation platform tied to an extraction system we've developed to extract out platform fatty acid chemicals, which have end markets in food and flavoring, beauty products, ultimately can be used to make bioplastics and biofuels. And really what this means is that we can work with existing AD infrastructure, we can build new fermenters and produce much higher value products, use much lower footprints, and pay these systems off faster. So, and what we're here is because we want to make sure that there's no limitations to our scale up. So we're looking for customers who are looking for green chemicals. Love to talk to investors if they're interested in working with this space. And anyone who wants to join a growing team, love to talk to you. You can reach me at the email here and LinkedIn. Thank you.
Thank you, Juan. Next up, we'll learn more how you can convert wet biomass waste to products. And for that, we'll have Jerry from NULIFE GreenTech.
Good evening, it's a pleasure to be here. NULIFE reduces disposal costs and emissions for waste generators. We use our patented hydrothermal liquefaction utilizing heat, water, and pressure. We take this wet biomass and we transform it into low carbon renewable crude oil and biochar. This will go for carbon sequestration, and a future market is upgrading into finished fuels. Both my co-founder and I have started, scaled, and exited 3 companies prior to NULIFE. So, according to the US EPA, over 290 million tons of high moisture wet waste is generated each year. Current disposal methods are becoming more expensive, becoming more restricted, and even being banned. So, in our pathway to commercialization, we've been through our bench testing. We've completed our large pilot. 1 ton per day. We have over 3,500 hours on that system. We've processed sewage sludge, food waste, agriculture waste, pulp and paper waste. We're now in the stage of we're building our advanced pilot. It's a 4 times scale up, and that brings validation to our peripheral equipment, and we'll secure contracts and generate that revenue. We're also going to be using it. We're working with a wastewater treatment plant in New York State. We've introduced through NYSERDA, and we'll be processing their material through it. Our next step is a 3 times scale up to a commercial module, and that is the intent to locate on the wastewater treatment plant in New York State. And that will become our US beachhead. On that note, thank you.
Thank you, Jer. Thank you, Jer. Yep. All right, we're almost there. So thank you for hanging around, and we'll close the finalists with a different approach, and the question whether you can use minerals to trap CO2 and solve it at the same time. And for that, I have the pleasure to welcome Sravans from Carbon to Stone.
Thank you, Fred, and good evening, everybody. The modern economy is putting piling up too many issues that are negatively impacting the atmosphere, whether it be tons of CO2 that we release into the atmosphere, or whether it be tons of alkaline waste that is just stockpiling every day from industrial waste. What we are proposing to do is imitate what nature is already doing to convert the excess CO2 in a mineral form. Except nature does it in a geological scale. It takes decades to convert the CO2 from air into carbonates. At Carbon to Stone, we've engineered an approach that utilizes CO2, whether it be from air, whether it be from point source, and combines it with industrial alkaline waste. This industrial alkaline waste could be your iron slag, your aluminum dross, and red mud, and so on. And this industrial waste is calcium and magnesium rich. So it allows us to effectively convert the carbon dioxide into carbonates. In addition to doing that, we are also able to extract valuable metals from this alkaline waste. This alkaline waste, which is stockpiled right now, includes calcium and magnesium. It includes a lot of energy critical metals that are actually utilized for a clean energy transition. And the way we do this is by utilizing electrochemical reaction to sort of leach out specific metals of interest from the alkaline waste, and also by utilizing recyclable solvents to convert the CO2 into carbonates. And on top of that, we are also able to generate carbon credits as part of the carbon removal. So we've been very successful in terms of identifying industrial partners that have these alkaline industrial waste. These include Nucor from iron and steel, Novalis from aluminum recycling, as well as Stillwater Critical Minerals. We are now working on developing pilot plants with each of these industry partners and looking to process about 4,000 tons of CO2 per year. And that's the goal for the next 18 months. We are very excited to be part of the Carbon to Value initiative and to convert all of this alkaline industrial waste into useful products that can support a circular economy. Thank you so much.
All right, well, thank you to the finalists for having traveled to here. I know you came from far away, for many of you, from the West Coast, from Canada, from France, from Germany. So thank you, and a big shout out to you. Can we give them a round of applause, please? They're going to stick around, so go, and I know you have a million of questions. So go and talk to them. This is a great opportunity. We'll now go from 12 finalists to 6 to 8 companies in the next couple of weeks. Once the core is selected, they will have access to the CLC partners, mentors, advisors, access to all the Greentown labs and Urban Future Lab incubator resources, and of course our larger ecosystem of partners, including investors. So I want to thank again to our main partners on this, NYSERDA, our main funding partners, as well as the contribution of all our Carbon Tech Leadership Council. I also want to give a super huge thanks to all the team that is working on this at Greentown Labs. Dom is here, Marina, I think she's here in the back. Tim is around as well. He's over there. I can see him. Noor, I can see her as well over there. Kelly and Jill, and really many more. Thank you for the hard work for putting this together. I also want to thank people from the UFL team. Jess, I can see her right here in the back. Meg, probably watching online, Rachel and Pat, and on the Fraunhofer team, Russ, Elliot, and all the Fraunhofer reviewers who have helped us down select. Thank you everyone on the team, and I think we can give them a warm round of applause. Most importantly, thank you for coming in person. Again, thanks for coming home. That's really cool to see a full house of Carbon Tech fanatics. Also people who have joined online, thank you for tuning in. It might be late if you are in Europe, so thank you for that. And really, now it's about you enjoying the party. So we'll have some drinks and some food. Enjoy, network, meet as many new people as possible, and I'll see you in the crowd. Thank you. And I have a special announcement to CLC members who join me on the stage for group pictures.